previous videos, we stored some strings in variables without really explaining. When a program's running, everything the program needs ends up stored in the computer's memory. The program code itself will be stored in one area of memory, and the data it works on will also be stored somewhere in memory. A variable is basically just a way to give a meaningful name to an area of memory into which we can place certain values. When we created the variable called greeting, Python allocates an area of memory for us. It knows to refer to that area whenever we talk about the variable greeting. Because we created greeting by attaching it to the string value, Python also decided that greeting was a variable of type string and ensures that we can only do things with it that make sense for strings. So there's a few rules for variable names. Python variable names must begin with a letter, either upper or lowercase, or an underscore character. They can contain letters, numbers, or underscore characters, however they can't begin with a number. Python variables are case sensitive, so greeting with a lowercase g and greeting with an uppercase g would refer to two different variables. Variables are created when they're first attached to a value using the equal sign. So in this code, strings.py, we've got a string with the value hello. That's on line 6, as you can see. We've attached the name greeting to it. Whenever we use the name greeting in our code, Python knows that we're referring to the string hello. On line 7, we use the input function to get some text from the user. Whatever they type in will be stored in memory, and we attach the name to it. And you can see there on lines 8 and also on lines 11, we use those variables to print out the strings. The Python documentation uses the word bound instead of attached. It would say that the variable greeting is bound to the string hello. So what we can do is create another variable called age and bind or attach it to the value 24 and then print it out. So let's have a go at doing that. So I'm going to come down to line 14 and type age equals 24. And the next line, print parentheses age. Right, so I don't want to have to keep typing my name in every time we run this program. So I'm going to go ahead and change line 7 here. I'm just going to change the input just to a double quote, or set of double quotes and the word Tim. Right, so if we run this now, I need to right click it because we're now using strings instead of escapechar.py. There's no surprises when we run the program. We get the two greetings printed, followed now by the value 24. In the introduction to Python video, I said that Python is a dynamically typed language and also a strongly typed language. This is a good time to see what that means. So I'll start by explaining what we mean by type. There are a number of data types built into Python, and we've already seen the string and integer types. Greeting is a string type and age is an int. But you don't have to take my word for that. We can ask Python what type it thinks they are. I'm going to go ahead and type some code for that. So we'll come down here on line 17. I'm going to type print parentheses type parentheses greeting and the two closing parentheses, right parentheses. Then line 18 print, same thing there, but this time with age. So type parentheses and age and the two closing right parentheses. So if we run this code now, you can see that Python reports that greeting is an object of type string, str, while age is an object of type int. And it's using the term class there, but we'll talk more about class a little bit later. But these abbreviations, str and int, are Python abbreviations for string and integer respectively. Python's got other types built in as well. The float type, for example, that lets you work with numbers that have a decimal part. We can also create our own types, and we'll be doing that later. So type, which is also called data type, describes the kind of information that we're storing. It's usual to talk about a variable being of a certain type, but it can be more useful to think of values having a type rather than variables. When we use the value 24 in our code, Python stores that value somewhere. The type of the value is int, it's an integer value. We bound the name age to it, which makes age have the type int. In Python, you can rebind a name to a different value. So for example, we can come down here and on line 20, I can type age equals, in double quotes, 2 years, So that stores now the string value 2 years in memory and binds the label age to it. That wouldn't be possible in many other languages. Once a variable has a type, you can only assign values of that type to it. Java and C are examples of languages that behave in that fashion. And that's why I said it can be more useful to think of the value as having the type than the variable in Python. Here, age is now bound to a string value. It's no longer an int, it's a string. So let's confirm that. I'm going to print it out and then print its type out. So we'll start on line 21, typing print parentheses age. On line 22, print parentheses type parentheses age. And we'll run the code. All right, and as you can see, we've now got 2 years and class string showing for our variable age. So line 20 looks like we're assigning the string value 2 years to a variable called age, and that would be true in other languages such as C and Java. In Python, though, it's more helpful to say that we've rebound the label age to the string value 2 years. So I'll finish by saying that programmers have been talking about assigning values to variables for now over 60 years. It's become the way we speak, and you'll find Python programmers talking in that way. And you'll probably notice me do it too in these videos. It's not wrong, but some things will make more sense if you think about a variable as a name or label that's bound to a value. All right, so I'll stop the video here, and in the next one, we'll see why Python is a strongly typed language. See you in the next video.